Hello everyone, welcome back for the third part of designing of the Risa 3D in metal building that we have earlier. Up to here we already applied the boundary condition, different loads, and we saw the result for that one. This is based on the member size that we have provided here, right? So uh, we just need to note down there like what was the member size we have given. You can just see, go to the section set and go to section set here. You can see the for the in column you have provided 24 by 94, 21 by 93, 21 by 44, 18 by 86, 10 by 22, and 21 by 50. We applied on based on that one. So today I'm going to show you how to use this design typical rule and how to find the exact appropriate uh, member size here. Okay, one thing based on here, like you can see the different load combinations, like load deflections here. Like when you run this one for the envelope one, I already saw everything. This is just the basic load cases that you have here for the different loads. Basic load combination 1 for the load combination 1, basic load combination for the 2, and if you see basic load combination 4, you can see the wind load application over here too. This is the transfer of your load into the different members. So let's get rid of this one here. One good news here is for Risa 3D, when you solve the problem, Risa 3D has process of giving the suggested solution for your members. If you go to the results section here, there is one point here is the suggested design. When you click this one, it will give you the suggestion for here. For example, for the in column, we were using 24 by 90, 24 by 94. That was, as I told you for the in the previous video, it's a very big size. They suggested just 18 by 97. This is on the member 45. And for the column, for member 21, you can use this size as a suggested, like 21 it reduced to 12. That's a lot. 21 again 12. B for 18 by 12, 10 by the 6, 21 by 50. You can just click on click and unclick of the suggested design here and change that one based on that. Okay, let's do here. You can just click on you can click an icon over here just to, it says I replace the current shape and wall design and resolve the problem, or you can right click on this table to show the same thing, solve again using the suggested shape. Okay, let's click on this one. So it says like, do you for the it asks for a suggestion like, do you wish to continue, like remember we don't have any masonry wall or we don't have any wood wall here, so we have members, that's fine. Let's click on OK. It's running for the load up to load combination 3. So now it changes into those load combination and it's still giving some more suggestions. We can apply that on later, not a problem. Let's see the basic load bending moment diagram here. It looks pretty fine now. Okay, let's go and see the unity bending here. Unity bending is still looking, this blue is still blue there, so it's very less in unity bending. Other are, like as I told you, it should be near to 1 but less than 1. So see, this one is 0.81, 0.69, 0.78, 0.24 are still less, the blue one, and pink one is 0.95. If you can design all this together with the pink one, it will be great. Yeah, okay, let's go for more suggestion. Let's see what is gonna see here. It says in column member 45 to change from 18 by 97 to 18 by 86. Yeah, little bit smaller. Column, other columns probably 12 by 65. It's increasing here. We can just unselect here, just it will not do analysis on that one. Girder is 12 by 79 to 12 by 72. Okay, let's run it again. Let's see what's gonna happen here. Okay, now it says the column to little bit bigger size. We don't need to do that one. Like it's still working, then why do we need to go for the bigger size? Like, okay, this is the appropriate member size given by the Risa 3D for you. Like these are the unity bending. So let's go and know. And if you go and see the spreadsheet now, it has been totally changed here. We started from the in column of 24 by 94, it became to 18 by 86, and all others are changed here. For the girder, in girder, it has been become a little bit bigger, like the unit load here, 14 by 109, but it's still smaller than the previous one that we used for 24 by 50, like 24 uh, inch of depth is too high as compared to the 14. So this is the way how you are going to assign the different sections, say section set based on the result and the suggested solution from the Risa 3D. And one thing I wanted to tell you here is, okay, let's go and see the description of the each one member at least. Okay, let's go and apply the most affected load combination, probably load combination 3, and see the deflection on one member. Or like as we saw in the last time, there was KL by R was greater than 200 for a girder, right? Let's see this time what's happening here. Detail and go for the load combination girder here. Now we don't have that problem. Now we have 0.434, and that load sorry, that slenderness ratio is not more than 200. If that one is the case, it's not going to solve here. So the bending check is this one, location is like maximum bending, where the maximum bending is that one, it's given there. All those things is giving over here. Not a, it's pretty easy. And for the KL by R ratio, previously it was more than 200, but here you can find out it's 173.68. That's very nice, less than 200, but it's 173. And as I told you previously, this giving the load. This is giving the deflection, this is giving the shear force, bending moment diagram, axial force diagram. It's all giving those things. So you can play with these things and find out the appropriate members here. One thing I just wanted to note down here for you is these are given by the Risa 3D. What if you want to apply your own members? Like for example, you knew that, right? You knew that the sizes that you applied was very big and you want to go down. But why every time we need to go from here? Do you need to go like 12 by 65 to 14 by 61? Why? What if we want to go to 14 by 65? Like your market might have available. We need to think about the market availability also, right? So for that one, there is a button over here into the data entry. You can click on that member design rule. If we click on this one, and for you can just assign a rule here. For example, if I assign rule 1, and if you, and this one is maximum depth, how much you want to go. For example, will be there again. For example, for the, if you go to the section set that we have now, I'll just do for only one case. Yeah, this is already given design rule, it's already given the rule 1 here. Okay, so for example, I want to change for anyone. Okay, let's go for this thing actually. In girder, we have W14 by W, we have W14, right? W14 by 109. What if we want to change a little bit on that one? Let's go, and what are the member design rule? Maximum depth, how much do you want? Minimum depth, how much do you want? Maximum width, how much do you want? And that one, and maximum bending moment is always 1, right? And maximum shear is always 1. So let's go and check the rule 1, and for that one you need to go to the code, AISC code book. For now, what you need to do, where do you need to go is, you need to find out the W14 by 109 that we have there. Let's go to W sections. WT section, W section should be there somewhere. We are still W2, WT. angle sections, and the first one is about the W section. Let's go up. Yeah, we are here to W sections, and we what we selected is 14 by, how much was that? 14 by 109, right? 14 by 109 is here. This is the 14 by 109 size. Yeah, everything is given here. So what if you want to select a little bit smaller size or bigger size? Like on that Risa 3 section, you need to add the depth and the width, right? For here, you can see the width is 14. How much is that? Is here 14.6, and depth was 14.3. Let's go little bit smaller. For example, what if I want to choose 12 size but a little bit bigger in unit weight? Let's make 12 in depth and 12, okay, in the range of 12. So let's go and change that one and we'll see that. Maximum depth just 14. Minimum depth you can choose, like this means W14 size is maximum size, W10 will be minimum size. Maximum width is width of flanges, you can choose in your way, like maximum minimum is 8. You can choose any one of those. Like that means it will choose in between W14 or W10, but width just 39.8, because in that our case the width was 14 point some 14.3 or something. So I don't want that member. Let's change that one. This is the member we have, or the available member in the market. So let's cancel it and go to the spreadsheet again and go to the section set, and design rule are, if you want to apply on all of those, that's fine, but if you don't want to apply on all of those members, section design rule, hit enter over there. This is R2 is the rule too. So let's see. Section set, I want to apply that is only on the inverter, and other are R2. Or you can click on this one and select the R2. That's not a big problem. And this is the I want to use rule one. Okay. Now you can click on this one and you can run it. Let's run for the envelope and ask for the suggestion now. Okay. Now you have done the solution and ask for the suggested design now. In girder, it did not find any shape, but for the column, it found a little bigger. But this means we cannot choose the smaller size than this one. Like we can go for the 16 or something like that. Okay, let's send that one again, and we will see that. Member design rule. If you want to go for the bigger size, okay, let's go for 18 size, and minimum depth you can go for any size, but minimum width you can go to 20, and okay, let's go for this one and run it again. Now see the suggested sizes. Now you don't have that thing, because our that 18 by 14 by 109 member was already better member than as compared to the like it don't need any suggestions, because that is the most appropriate member already we have here. So based on the rule 1 that we applied, we found the 14 by 109 member size was excellent for that one. For example, if you want to see the changes, probably we can see another one. Okay, let's apply in column. Column they want already change, right? Okay, let's go and apply an in column and run it again, and let's see if there is some suggestion for the in column. Go to suggested design. Now we have in column suggestion, like it is applying the 18 by 86, but it want 14 by 99. It will work for that one. That is the smaller size. Now you can click on that one and solve again using the suggested size. It still has this is the bigger size than the previous one, so we are not going to use it. And in girder it gives the sizes, but a little bit bigger one, we are not going to use that one. Now if you go and see the unity bending, the unity bending of the in column should have been increased. But here, this is the problem. Int girder has the problem. So now we need to use anyhow this int girder one. Let's don't use the int column, but for int girder, let's solve based on the solid state design. So it should go from red to some other color, yeah, or into green color. So this is the way how you are going to play in the Risa 3D to select the exact appropriate member size that you are going to be needed for your stock. For example, for me, as I found these stocks, these members are pretty good. Or as I told you, if there is some problem in the market of these members, we can change based on the design rule, right? So, and I forget one thing to tell, show you like the code check. The last time when we see the design result, those were in code check, there was some problem into the KL by R value, right? But here, there is no problem now. Here you can see in the code check, it has all the value given here and different step based on your the final data. If you want to see this section set of the what was my final size of those things, you can see here. This will be your final member for your use actually. So this is the way how you are going to assign your members for your structure. And yes, okay guys, if you have any questions, any confusion and any queries about these design problems, you can comment below into the comment box, so I will be able to answer you from there. So thank you for watching this.